Why is Zeckendorf's theorem important for Fibonacci? Imagine trying to break down a big number into smaller parts without any overlaps or repeats. That's what Zeckendorf's theorem helps us do with Fibonacci numbers. It shows us a special way to write every positive whole number as a sum of Fibonacci numbers. But here's the twist. No two Fibonacci numbers in the sum are allowed to be next to each other in the sequence. This rule makes the way we representing numbers unique and easy to understand. Let's start with the Fibonacci sequence itself. It begins with 0, 1, 1, 2, 3, 5, 8, 13, and keeps going. Each number is the sum of the two before it. Zeckendorf's theorem says that any positive number can be written as a sum of Fibonacci numbers, but with the rule that no two are consecutive in the sequence. For example, the number 10 can be written as 8 plus 2. Both are Fibonacci numbers, and they are not next to each other in the sequence. This way of writing numbers is always unique, meaning there is only one way to do it for each number. Why does this matter? Well, it gives us a clear way to break down numbers into Fibonacci pieces. This is called a unique representation. It's like having a special code for every number that uses Fibonacci numbers. This idea is useful in computer science for data compression, where it helps store information more efficiently. It's also used in error detection, making sure data is correct when sent from one place to another. Another reason Zeckendorf's theorem is important is because it reveals hidden patterns in numbers. It shows that Fibonacci numbers are not just a sequence of random numbers, but are fundamental building blocks for all positive integers. This understanding helps mathematicians see connections between different parts of number theory and the natural world. The theorem also supports algorithms that find the Fibonacci sum for any number. These algorithms often use a simple method called a greedy approach. They start with the largest Fibonacci number less than or equal to the number and keep subtracting until nothing is left. This process is quick and reliable, making it practical for computers. Scientists and mathematicians also look at how this idea can be expanded. They study similar rules for other sequences that follow Fibonacci-like patterns. These studies help us understand more about how numbers work and how different sequences relate to each other. In the world of numbers and their meanings, Zeckendorf's theorem connects the Fibonacci sequence to every positive integer in a very organized way. It shows us that Fibonacci numbers are more than just a pattern. They are fundamental pieces of the puzzle that make up all numbers. This connection helps us see the beauty and order in the way numbers are built and how they relate to natural phenomena.